Hi everyone, I wanted to go over how to calculate an empirical formula with you because it's something you need in the lab, and I think it can be a little bit tricky if you don't actually see someone go through the steps, but I think once you see it, you'll have no problem with it. So I'm going to use this example of zinc chloride in this little lower section, so down here. So this is in your lab experiment, and they kind of go through the steps, but I wanted to write them out with you. And so you can get a good idea about how to actually do this. So basically what we're saying here is that we've determined that a compound has a certain number of moles, or actually in the lab you'll find that it actually has a certain mass of two different elements, or it could be more than two. But in this case we're dealing with zinc and chloride. And here they give us the moles, but what I actually wanted to do, if it will let me, here we go, is start from the mass. And the reason I'm doing that is because in an actual lab setting, or even in the lab that you're doing today, what you'll do is you'll find mass data like this. So you'll say, with today's lab, you're going to actually heat some magnesium and turn it into magnesium oxide. And what you'll be able to find is how much of that is magnesium and how much of it is oxygen. And you'll do that based on mass. Excuse me. Okay, and so here, instead of starting from mole, let's start from the actual masses. So let's say that we did our experiment, and from our experiment we were to determine that our compound is, or our sample is 2.616 grams of zinc and 2.836 grams of chlorine. And what I've done here is I've just kind of back calculated from the number of moles they gave. So it's the same example, but I'm starting from the mass instead of just jumping straight to moles. So, and the reason I just want to show you and make sure that it's well solidified. Okay, you're given this data. Now what do I do with it? Okay, so first thing we want to do is we want to convert these both to moles. And this is not a difficult calculation. So we'll start from the zinc. So we'll say that we have 2.616, and that's grams of zinc. We want to convert this to moles. Okay, so how do we do that? Well, we need to go to our periodic table, find zinc. Okay, so element number 30 over here. Okay, so find zinc, and we look at its molar mass. So its molar mass is 65.39. Okay, so that's grams per mole. What do we want? We want mole. So for every 1 mole, there's how many grams? Let's go back. 65.39. Okay, so there's 65.39 grams. Notice I'm putting moles over grams because I want to end up with moles in the long run. So let's see how many moles this actually is. Okay, so grams will cancel with grams, and I will then take my calculator, and I will say 2.616 divided by 65.39, and that gives me 0.04, let's say 0 moles. Okay, we'll do the same thing for the chlorine. Okay, so we'll start from 2.836 grams of chlorine. Okay, then we go back to our periodic table. We find the molar mass for chlorine. Okay, and here we have 35.45. So 35.45, and that's grams on 1 mole of chlorine. Okay, so calculating this, again, I'll take 2.836 divided by 35.45, and that gives me 0.080 moles. Okay, and it's helpful to go ahead and write in your labels completely. So that's zinc and this is chlorine. That way we don't mix them up later. So now what we want to do is we want to just find out, so that was kind of the first step, going from mass to moles. And now what we want to do is we want to find out and just look by inspection at the two numbers, or by inspection, see which one is smaller. So in other words, I'm comparing 0.04 and 0.08. Well, obviously 0.04 is smaller. So in other words, you're looking for the smaller number of moles. And what you'll do with that, I'm going to change colors just for the sake of clarity. So what I'll do now is I'll find the smaller number of moles, and I'm going to divide both sides by that number. Okay, so both sides divided by 0.04. So in other words, one of them should always equal 1. I'm just going to slide this over. and we'll find out the solution to both of these. So the first one, of course, that's just a 1. And the bottom one, 0.080 divided by 0.040 is, of course, 2. Okay, and if these numbers are not whole numbers, you may need to do some rounding. So if I came up with, for instance, 1.0, I don't know, let's say 0.5, something like that, I could round that to 1. Okay, but if I came to, say, 1.5 or something like that, that's not going to work. Don't round numbers like that. Okay, and for this example, I'm not going to get too deep in that. But now that I know that for every, basically what this is telling me is for every 1 mole of zinc, I have 2 moles of chlorine. So my empirical formula then, if I just bring this information down, okay, so I'll just write my 2 elements. So I have zinc. Oh, I can write a better Z than that. So I have zinc, and I have chlorine, and I'll leave a little bit of space. And now what I'm going to do is just drag these numbers down. So I end up with Zn1 and Cl2, which of course we don't need to write the 1s. So we'll write zinc. Oh, that's not it, is it? I'm having trouble writing Z's today. Zinc, and then Cl2. So this would be my empirical formula. Okay? Oh, sorry, with the 2. Okay, so that would be your empirical formula. And so just to go back to our actual lab here. So that's all the steps in finding the empirical formula. So let's go back to our lab, and I want to show you a couple of things about the way they wrote this lab up that might be a little bit confusing. Okay, so the first part you should have no trouble with. Okay, then this is where you'll fill in the data. So you'll watch the videos and you'll say, okay, they weighed the crucible and the lid. I'll write that here. Then the mass of the crucible, the lid, and the magnesium, I'll put that here. And then the mass of the crucible, lid, and oxide product, you'll put that here. Okay, and so those 3 numbers, based on subtraction, so in other words, just how much did the mass grow each time, the difference between the 2, you can figure out, for instance, the mass of magnesium. How will I figure that out? Well, I'll take the mass of the crucible, the lid, and the magnesium, and I'll subtract the mass of the dry crucible and lid. Okay, so that will give me just the mass of the magnesium. Okay, so then the next one is, what about the mass of the magnesium oxide product? How will I find that? So again, I will take just the mass of the crucible, lid, and oxide minus the mass of the minus the mass of the dry crucible and lid. Okay, so that will tell me the entire mass of the oxide product. So that includes magnesium. Please note that that's including the magnesium. So the next one, it says just the mass of the oxygen. So how will we find that? Well, if we know the mass of the magnesium oxide product, we know the mass of the magnesium. If we subtract the 2, that gives us what? What's left over? Just the mass of the oxygen. Okay, so that puts you exactly where I started on the zinc example. So here we're looking at mass and oxygen, but the process will be exactly the same. Okay, so you'll come down here, and then you can convert to moles of magnesium. Moles of oxygen. So again, go to your periodic table, find your molar masses, convert to moles. And then here it's asking you just to rewrite the moles of magnesium, the moles of oxygen, find the smallest. So if you remember, that was this step that I did in red. So remember I said find the smaller number of moles. In this case, it was a 0.04. So that's what it's asking you to do here. Just find the smaller number of moles. And then I thought this part might be a little confusing, but what they want you to do is take moles of magnesium, moles of oxygen, and then divide by the smaller value. Okay, so they're trying to set that math up for you. It might be a little confusing, but they're trying to set that up for you. So just divide by the smaller number of moles, then that will should give you the whole numbers for the moles of magnesium, moles of oxygen, and then you can write your simplest formula into A13. Okay, and then you have some questions to answer. Okay, so you might be asking, why would I ever need to do this? And the answer to that is that you might not know the identity of a sample. So for instance, one way of proving or or demonstrating or backing up, I should say. So a piece of data you can write into a report if you're saying, hey, I made this compound, or maybe you're a state scientist or a city scientist and you're trying to say this compound was found in the solution, or this compound was found in the sample. This is one way of doing it. And so it just works as a way of identifying substances. And maybe you didn't know exactly what the oxidation state of magnesium was. Okay, so this might be one way to find it. So maybe you have gold and you have some anion, and you want to know exactly what the ratio of those is. So this is one way you could find it. Okay, but what this ends up giving you is the empirical formula, and from there you could find the molecular formula. So the lab doesn't ask you to do that, so I won't get into that too far. But it's literally just one more step. If you know the molar mass, you know the empirical formula, then you can go to the molecular formula. Okay, but you don't have to do that for this lab. So here, they're just asking you to stop at the empirical formula. Okay, so hopefully that was a useful explanation of finding empirical formula.